Hello. For this video, I'm trying something a little bit different. I'm writing out the expression ahead of time because I want you to be able to very clearly see how each of the expressions we look at today relate to each other, how similar they are, and what their differences are. I don't want my handwriting to get in the way of that. So here's our first expression, and I would like you to simplify this. Go ahead on your paper, give that a go. You know everything you need to know. Okay, this is a like terms situation here. Simplify means, right, perform all possible operations. 2 times x, I can't perform that operation unless someone tells me the value of x. 2x plus 3, I can't add 3 to a number if I don't know the quantity of that number. But I do know what 3 plus negative 9 is, right? Because addition is commutative, I can make this minus a plus negative, use the associativity and commutativity of addition to say 3 plus negative 9. Let's try that again here. 3 plus negative 9 is negative 6. And 2x plus 5x, 2 plus 5 more, that's 7x. And I'm done. And I could leave it like this. If I put the 7x first, that's very common. 2x plus 5x is 7x. 3 plus negative 9 is negative 6. This is not considered fully simplified, right? I would need to write that plus negative as minus. And then I'm all good. Okay. Let's look at this problem now. How does this expression compare to this expression? Okay, we have grouping symbols now. So what's being grouped? I have this addition between these two terms separated out from this addition, right? Minus is always going to be the same as plus negative. So I have plus and plus and plus. We already talked about how rearranging these terms is possible because I can associate this term with this term. These parentheses are encouraging me to associate these two terms, but I know I don't have to do it that way. When we're adding, I can add whichever term I want to whichever other term. Right? That's how we can deal with 23 plus 59. I don't have to associate the 20 with the 3. I can associate the 20 with the 50 to get 70. And then do 79, and 79 plus 3, 80, 81, 82. I don't have to associate these two together. I can associate these two, even though that's not how it's written. Same thing here. 2x can be associated with the 5x. I can write it that way if I want. 2x plus 5x, there's my 7x. And then the 3 and the negative 9. When we did our Zoom quiz, a lot of you took the time to rearrange the terms, and that's fine. It's not technically necessary so long as you're rearranging them in your head, right? Writing this step, if that's helpful for you, fantastic, you can do that. But don't feel obligated that that's a necessary part of showing your work if you're kind of recognizing that in your head, that this goes with this, and then this goes with this. Good, however you're underlining or indicating that. All right, third problem. How does this expression compare with the one before it? We still have the grouping symbols, but now instead of a plus here, I have a minus, and minus means plus the opposite. So I have plus the opposite, but that interaction happens to whatever the minus applied to. I'm not just getting the opposite of the 5, I'm getting the opposite of this whole parenthesis. Every term inside here is being multiplied by -1. I'm distributing that -1 to each of those terms. So do I have a negative in front of this parenthesis? No. So I have regular 2 with the x, a regular 3, then the opposite of positive 5, which is -5 with my x, the opposite of -9, which is positive 9. Right? I can write this minus as a plus negative, just like I did before. And then I could say plus the opposite of -9. But it's kind of annoying to have to rewrite everything. 2x plus 3 plus -5x, just to rewrite this minus negative as plus. So we often just distribute that negative. The opposite of 5 is -5. The opposite of -9 is positive 9. Right? I'm distributing this negative to reverse each sign in the second parentheses. Now I'm looking at my like terms, 2x and -5x. 2 minus 5, that's -3. 3 plus 9, right? It was minus -9, so that's plus 9. 3 plus 9 is 12. And I'm done. And again, if you like putting the positive term first, that's fine too. Just don't write it as a plus negative. I'm going to write it there. But either of those are perfectly good. And that's all adding and subtracting polynomials is. If we look at a more complicated example like this one, now I have 3 terms in my first set of parentheses, all one variable, but these are separate terms, right? If x is 10, this would be 200 plus 30 plus, well, I guess those would be like, since that's 40, right? But if x was 7th, this would be 2/49ths plus 3/7 plus 40, right? These aren't the same units here, so I can't combine anything within these parentheses. Over here I have 3 more terms that are being added. So how many total terms do I have here? 3 terms in the first polynomial, 3 more in the second polynomial. I'm adding them, so that makes 1, 2, 3, 4, 5, 6 terms. 6 terms total. But if I have any like terms, I want to combine those. So here's an x squared, x to the 0, x to the third, x squared, there's another x squared. So I have a 2x squared, and here's a minus 7 x squared, so that's -5 x squared. Done with those. I'm not canceling them, I'm just checking them off my list. Now, here's an x. No, already used up. X. All right. 3 positive, 16 positive, 3 plus 16. That's 19. Okay, check those off my list. Now 40, that's no x's, 40x to the 0. No, only thing left over here has an x to the third. So I could say this is my answer. I have no more terms that are like terms. I can't do any more adding or subtracting. The only multiplying is within each term. It's not 5 times 2, it's 5 times a couple x's. I can't evaluate that until someone tells me the value of x. So I'm done, except for the second half of our simplified definition. Okay. To simplify means perform all possible operations and follow mathematical conventions of syntax, or standard conventions of mathematical syntax. Change up that language every time. But basically, is this fitting the form that I want it to fit? When I have linear polynomials, sometimes we like having the x term first no matter what. Sometimes it's kind of nice to only have minus instead of starting with a negative. If we're graphing these, we have like y equals mx plus b, so there's mx plus b. When we're dealing with word problems, sometimes we have fixed costs plus variable costs, so we want the constant term first. When we have a polynomial, there's less ambiguity. We almost always want it to go from the highest degree term down to the lowest degree term. So the highest degree term here is the third power, right? 3 is bigger than 2 or 1 or 0. I could show those 40x to the 0, 19x to the 1, right? And then I can count 3, 2, 1, 0. So my final answer here, 5x to the third, and then negative 5x squared. So instead of writing plus negative, I'll just do minus 5x squared. Next highest exponent is 1. There's my 19. But since x to the 1 is equal to x, I'm just going to write it as x. That's more simplified. And then after 1 comes 0. And again, x to the 0 is 1. So I'm not going to write 40 times 1. I'm not going to write 40x to the 0. I want it fully simplified. So here we go. Right. One last example. Now, I didn't put these on the same screen because I knew I would be taking up more space here. But it's the same problem, except for what? Right. This minus has to be applied to each of these terms. So the 2x squared, the 3x, and the 40, those remain unchanged. But I have the opposite of 5x squared, or cubed, the opposite of 5x cubed, the opposite of negative 7. So that's positive 7. The opposite of positive 16. So that's negative 16. Right? Now I still have those 6 terms. Now that I've distributed that negative, I don't care about what's being grouped with what, because it's all just addition. Right? Now, one approach is to do what I did the first time. Start with the very first term reading left to right. But if we know we want our final answer in standard form, it can be a little bit faster if I just hunt down the highest degree. So here, 3 is the highest power we have here, so that's going to come first. That's my only x to the third term. So there's my x to the third term. Then I'm looking for my x squared terms. Oh, here's one, and here's another one. So I have a 2 and a positive 7. 2 plus 7 is 9. All right, done with those. And then I move on to the x to the first term. Here's a single x. Here's a single x. Positive 3, negative 16. 3 minus 16, negative 13. And then here's a 40, so plus 40. So let's double check. Third power, second power, first power, 0th power. So no more like terms here. I don't have any plus negatives. I'm good. Whenever we're writing a simplified polynomial, we want it to be in standard form like this.